Hello all, so good evening all of you. I hope all of you are fine and the audio and video is fine. Okay, so let's start quickly the lecture number 7 of this engineering maths is in differential equations. So this is lecture number 7 of differential equations, and in this particular lecture we are going to focus on particular integrals, because in the last lecture we have seen how to evaluate complementary functions of higher order linear differential equations and of course with constant coefficients. So in today's class we'll talk about the particular integrals, and then we'll also see some generalized procedure which is called as method of variation of parameters, or basically the Wronskian method. Okay, and we'll see again some conversion, like one special case where we can actually evaluate the equation with variable coefficients. Okay, so we call them as Euler-Cauchy equations, and we'll we'll calculate the solutions of Euler-Cauchy equations in today's lecture. Okay, so let's see, before I straight away start this, I would like to give this Telegram channel on Wallah English Telegram channel actually, so that you can have you can basically join this and get all the updates that regarding the things that happening on this particular YouTube channel, on this Telegram channel. Okay, and also this is our personal Telegram channel, so basically if you just join here you can get in access with me, and one basically we have already some 1500 plus of our friends who are again focusing on various exams like GATE, all basically in the technical side. So you can get in contact with all of them so that you all can stay in touch. Okay, and also I advise you to install Unity, so that once you create your login and then once you have basically your your account, then you can have all the status at a particular location. Okay, so that would be again so beneficial for you guys. So basically when you're typing a doubt in the chat box, you can actually type it as exclamation doubt, and when you have a note you can also type it as exclamation note, and if you make the points, then these points will get stored in the PW Unity place actually. Okay, so let us have a quick revision of the last lecture. So in the last lecture I have given you the general form of an ODE, the general form of an higher order ODE, which is a linear, of course, linear and constant coefficients, linear and constant coefficients. So if you have seen this, the general form of this equation, then we got the form like something like this, basically d for n y by dx for n, so in then the derivative plus k1 n minus 1th derivative, k2 n minus 2th derivative, and so on, plus k n minus 1 operating on y plus kn, or basically kn minus 1, the first order derivative, dy by dx plus kn operating on y is equal to some function in terms of x actually here. Okay, so this is what this is what we have seen, and to write this solution of the differential equation, we have written the solution in two parts, so which is yc plus yp actually here. So this yc is complementary function, of course, complementary function, and in this complementary function basically it tells you the solution of the homogeneous part. Okay, so this is solution of homogeneous part, solution of homogeneous part. Okay, homogeneous part, like you have seen, when you make the right hand side function to be 0, then ultimately the equation is a homogeneous higher order equation, and whatever the solution you get for yc, or basically whatever the solution you calculate in terms of yc, that's basically the solution when x is actually 0. Okay, and we treat, and we have also seen this can be written as some function, some polynomial operator in d operating on y is equal to x, where d is the differential operator. So it's like if you have d twice, you can do 2 times differentiation. If you have things like 1 by d and all, it's like the inverse of differential, which is integration actually. Okay, so let's see, and this yp is actually the particular integral actually. Okay, so this is particular integral, and this particular integral is basically solution of non-homogeneous part. Okay, this is the solution of non-homogeneous part actually here. Okay, so this is non-homogeneous part, so this is yp and this is yc actually here. And in the last lecture we have seen the rules for writing the complementary function, and we have worked out certain examples. So in today's class, if we can figure out how to write yp, then the job is done, of course. Okay, so basically we can then write the total solution of the differential equation. So that's why in today's class the prime focus would be on calculation of particular integrals, and we'll also discuss a bit on Wronskian, the general technique for solving any linear higher order differential equation, and we'll also talk about Euler-Cauchy equations actually. Okay, so these are the things which we are going to discuss in today's class actually. Okay, so is each and everything clear to all of you? Please type it in the chat box. Okay, so let's based on the before I start today's lecture, based on the previous understanding, let us try to solve a question. Okay, so solve this question. The general solution of the given differential equation d power 4 y by dx power 4 minus 9 d cube y by dx cube plus 19 d square y by dx square plus 9 dy by dx minus 20 is equal to 0 actually here. Okay, so solve this question. I'm giving you poll actually, so single choice. Maybe I'll give you some say 120 seconds. Start. Solve this question. The chat box was. So solve this question. The given dE, just I'll write the given differential equation. Solution, we have d power 4 y by dx power 4 minus 9 d cube y by dx cube plus 19 d square y by dx square plus 9 dy by dx. This is minus 20 y actually. Okay, so this is 20 y. I think the y is missing here. So minus 20 y is equal to 0. So solve this. If I start preparing for the gate now, can I crack it? Yeah, definitely 6 months is more than enough. But you should start and be consistent. Okay, that's the only thing. Okay, so the time is almost up. Then let's the poll get stopped. So let's solve this equation. So this tells you auxiliary equation is auxiliary equation is m power 4 minus 9 m cube plus 19 m square plus 9 m minus 20 is equal to 0 actually. Correct. Then option B. Okay, maybe I don't know. Let us solve. So option B is not the answer, I think, right? Because I think some part of the solution is missing here, because only 3 constants are there, but it's a 4th degree equation. Okay, it's a 4th order equation, sorry. Then let's see in this case. First of all, with the principles what we know, let us try to look at the sum of the coefficients. Okay, so sum of the coefficients, if you calculate, this is 1. So 1 minus 9 minus 8 minus 8 plus 19 11 11 plus 9 20 20 minus 20 is 0. So sum of the coefficients is 0. This implies m equal to something is out. So can you tell me what is the value? If sum of the coefficients is 0, then what would be the one root of that equation? Please type in the chat box. If you have a polynomial equation and if sum of the coefficients is 0, then what would be the root of that particular equation? One of the root, of course. Come on, I have told you in the last class, and of course we have talked well about the equations in the linear algebra as well in the matrices. When sum of the coefficients is 0, then what would be the value, which is one of the solutions of the equation? The last lecture we were talking about that, right? So m is equal to 1 actually. Okay, so m is equal to 1 is a root definitely here. Okay, also you can check one thing. Sum of coefficients of even powers of m even powers of m is equal to sum of coefficients of odd powers of m. Actually, sum of coefficients of odd powers of m. Okay, so clearly you can check 1 plus 19, 20, 20 minus 20, it is 0. Similarly, minus 9 plus 9, this is also 0 actually. Okay, so sum of coefficients of even powers of m is same as sum of coefficients of odd powers of m actually. So this tells you m is equal to minus 1 is a root actually here. Okay, so this tells you m equal to minus 1 is a root. So 1 comma minus 1 are two roots of this equation. Okay, but this is a fourth degree equation, so we have two more roots actually. Okay, so let's figure it out. Let 1 minus 1 alpha beta are roots, then ultimately this implies sum of the roots 1 plus minus 1 plus alpha plus beta is equal to minus of second leading coefficient by first coefficient. So minus of this minus 9 by 1 actually here. Okay, so minus of minus 9 by 1. Then let's take the product of all the roots alpha beta. So if you check it up, so this is into alpha times beta is equal to, so if you multiply alpha and beta, so we'll take a minus sign here, so no minus here, minus sign here, and no minus, so it is like minus 20 divided by 1 actually. Okay, so you can figure it out, this minus and this minus cancels, and minus plus 1 and minus 1 cancels up, so minus of minus is plus. So alpha plus beta is equal to 9 and alpha beta is equal to 20. So ultimately alpha comma beta is equal to 4 comma 5 or maybe 5 comma 4, whatever. Okay, so once you have this solution, we figured out the roots of the equation are, therefore roots are minus 1, 1, 4, 5. That's it. Okay, so what would be the solution then? Y is equal to c1 e power alpha x, which is this minus 1 into x, plus c2 e power x, plus c3 e power 4x, plus c4 e power 5x actually here. That's the solution. Okay, also if options are given in these cases, you can add, when you add these powers of when you add these coefficients of x like minus 1 plus 1 then 4 and 5, if you add this if you add this what do you say, coefficients of x, this coefficients of x should satisfy the sum of the roots, which is happening only in this case. Okay, so you can see minus x plus x e power 5x and e power 4x with constant. So C is the actual answer in this case. Okay, so C is the correct answer of course in this case. Clear? So C, what is C? So let's see. Oh, none of you, some of you have marked B actually. Okay, but B is not the actual answer, C is the correct answer in this case. Okay, because here there are only 3 arbitrary constants in the solution, but the equation is of a fourth order equation, so ultimately it's you have to be careful, and C is the correct option. Okay, fine. Oh, thanks. Okay, so let's now focus on particular integrals. Okay, so once we focus on the particular integrals, then we'll start looking at the questions again. Okay, so first case, f of d operating on y is equal to exponential function. So let's say it is something like e power ax. Okay, then ultimately what you teach on YouTube is enough, because I purchased a English batch. I don't know Hindi much. Then you can shift to English batch. No, Girish, why did you take Hindi batch if it is not very comfortable? It's okay, fine, whatever. So let's see, this tells you yp is equal to 1 by f of d operating on e power ax, correct? Now how do we solve this question? How do we solve this example? Let us check here. So this tells you yp is equal to 1 by f of a times e power ax. So whatever the function you have, f of d, just we replace d with a in the case of exponential function, and we have 1 by f of a e power ax. If f of a is not equal to 0, okay, then if f of a is equal to 0, then yp is equal to x into 1 by f dash of a times e power ax. Again, f dash of a not equal to 0, and in general this loop keeps repeating. Okay, if f dash of a is equal to 0, then yp is equal to x square 1 by f double dash of a into e power ax, if f double dash of a not equal to 0, and this loop goes on, okay, like this. So let's solve an example, maybe to get some interesting understanding. Let's solve a couple of examples which makes you understand few points very clearly. So the first example is solve d square y by dx square minus, let's take the sum nominal value, dy by dx plus 6 times y is equal to say e power 4x. Clear? So let's take it to be e power 4x. So if you want to solve that equation, so clearly it's a non-homogeneous equation because we have a term involving only a function of x, of course, okay, without involvement of y. So first let us calculate complementary function. So solution, clearly you know yc we all can identify by this time. It's going to be something like c1 e power 2x plus c2 e power 3x, right? Because if you write auxiliary equation, m square minus 5m plus 6 equal to 0, so m equal to 2 comma 3. So if m is 2 and 3, then ultimately the solution is c1 e power 2x plus c2 e power 3x actually, which is a very nominal way you can figure it out by now. So the main crux is to calculate the particular integral, okay? So let's see calculation of yp. Calculation of yp actually here. So if you calculate this yp is equal to 1 by f of d operating on this e power 4x. So what is 1 by f of d? 1 by d square minus 5d plus 6 operating on e power 4x actually. So as per this you can check 1 by f of a, okay? So replace this d with this a actually here. So it becomes 1 by 4 square minus 5 into 4 plus 6 operating on e power 4x. This gives you e power 4x upon 16 minus 20 minus 4 plus 6 is 2 actually here. So therefore y, the total solution is c1 e power 2x plus c2 e power 3x plus e power 4x divided by 2, of course, okay? So that's the actual complete solution of this differential equation in this case, okay? So whenever this differentiation of this, or basically this value is non-zero, then we retain 1 by f of a into e power ax as it is, okay? Now when you go for the next thing, let's say for example if you have something like solve d square y by dx square minus 4 dy by dx plus let's say 4y is equal to e power 2x, okay? So let's say if you have a solution like this, then let's see how we calculate the solution. So firstly we can calculate what is yc, of course, okay? So yc is equal to, so first let's focus on yc, calculation of yc actually here, okay? So calculation of yc. So to calculate yc you need auxiliary equation. Auxiliary equation is going to be m square minus 4m plus 4 is equal to 0, and which tells you m minus 2 whole square is equal to 0. So which tells you m is 2 comma 2. So here the root is repeated, so ultimately we know the complementary function is going to be c1x plus c2 e power 2x, okay? So because it's a repeated root, so c1x plus c2 e power 2x. Now let's focus on the calculation of yp, okay? So calculation of yp, calculation of yp actually here. So let's see, yp is equal to 1 by d square minus 4d plus 4 operating on e power 2x. So now if you try to calculate if you try to replace this d with the 2 actually, let's see. So this tells you yp is equal to 1 by 2 square minus 4 times of 2 plus 4 operating on e power 2x, and in this case this value is basically 0, correct? Yes or no? That's what I have told you. Once if this is non-zero, f of a is non-zero, this itself is the particular integral like this, okay? But if f of a is 0 here in this case, then we'll go for a x and the derivative of this function with respect to d, and then put d equal to a actually. So therefore yp is equal to x into 1 by f dash of d. So what is f dash of d? D square, if you differentiate this function, we have 2d minus 4 operating on e power 2x, and if you replace this d with the 2 operating on e power 2x, again you will figure out this value is going to be 0, of course, correct? So that value is going to be 0. So this implies yp is equal to x square into 1 by, now once again you differentiate the denominator function, so which gives you 2, of course, operating on e power 2x. So x square e power 2x by 2 is the yp value actually here. Okay, so whenever you get this 0, it's like basically it all happens because of this differential operator d. But once you have the denominator 0, you can write a x here and then write it to be the multiplication in this, write it to be the derivative and then substitute d equal to a in this particular case. Okay, so therefore the complete solution is going to be c1x plus c2 operating on c into e power 2x into e power 2x plus this guy x square e power 2x by 2. That's the solution actually here. Clear? Did you all understand what you should do when the denominators are turning out to be zeros? Yes or no? Please type it in the chat box. Is this clear to all of you? Did you all understand with the help of examples what I have told in this particular theory? Yeah, just type a comment yes or no, because understood. Okay, so yeah, great. So let's solve an example. Maybe one more question I'll give you now. For you have to solve it by yourself. Come on, do this. The general solution of the given differential equation d square by dx square minus 7 dy by dx plus 12y. Okay, so plus 12y. I don't know why so many x were typed. So 12y is equal to e power 5x will be. So one of these solutions is the actual answer. So do this question, single choice, and yeah, maybe 120 seconds enough. On the time is rolling up fast and hopefully. So when you see this question, like two answers or two options can be straight away eliminated. Can someone tell me out of these 4 options, 2 options can be eliminated actually? Can someone comment what are the 2 options? I can eliminate 2 options by looking at this. Can someone tell me what are the 2 options I can eliminate? Just by looking at these options, I can eliminate 2 options. Can someone tell me what are the 2 options? No idea. Look, whatever is in the combination with C1 and C2, that's the complementary function, correct? So please be with me in the class. So whenever you are trying to calculate this complementary function, you will get some arbitrary constant. So whatever the part that is with arbitrary constants, that part will be corresponding to the complementary function, right? Now, everyone knows, if you try to make an attempt to solve this equation given, let's write the equation once. D square y by dx square minus 7 dy by dx plus 12y is equal to e power 5x. Okay, then, and obviously if you write auxiliary equation, you know auxiliary equation tells you something like m square minus 7m plus 12 is equal to 0. And we all know that this has the roots 3, 4. This much is known. If roots are 3, 4, then if you write a complementary function, the exponentials will have a power only 3 and 4, correct? And in the first option here, the exponentials are of negative powers. This is minus 3 and minus 4, which should not happen actually, correct? Because whenever you calculate this and by looking at this term, you can figure out that the roots are going to be 3, 4. So the coefficients on the top of exponentials should be only 3 and 4 actually, correct? So therefore this option is wrong because they are negative minus 3 and minus 4. Similarly, there is 1 by 3 and 1 by 4, which is actually wrong. Okay, so that's how you can actually eliminate two options, A and C actually, correct? Yes, is this clear to all of you till this point? Did you all understand how can I eliminate a couple of options out of these 4 options? Just type it in the chat box, all of you, everyone. Rambabu, Gesh, Penny, blogging, whoever, of course. Read only. So please type in the chat box. Is this clear? Can you all understand that these two options can be eliminated? Because if you solve the auxiliary equation, your roots are going to be 3 and 4, of course. So if roots are 3 and 4, the coefficients of x on the exponentials would be 3 and 4. But option A and option C do not have 3 and 4 actually. So we can eliminate them. Clear? This part is clear. And now if you check option B and option C, this is c1 e power 3x plus c2 e power 4x. This is also c1 e power 3x plus c2 e power 4x actually. Okay. Now tell me one thing. If you calculate particular integral, okay, the function is exponential function. It is e power 5x. So yp is equal to, so let's write this, c1 e power 3x plus c2 e power 4x. Then let's come to yp calculation. Yp is equal to 1 by d square minus 7d plus 12 times e power 5x. This is what we have. Now tell me one thing. Whatever you do, this final solution will have this e power 5x. Yes or no? Means if you substitute 5, if it's non-zero, okay, then ultimately e power 5x by something. If this is 0 in this case, you'll have x multiplication x by some constant into e power 5x. Whatever you do, this e power 5x stays as it is. Correct? I think I'm not getting the comments, right? Because some of you are maybe responding, but I could see very limited comment. Yeah. Okay. Then, if that's the case, ultimately, you should not have e power minus 5x here. This is e power minus 5x, which is wrong, of course. Okay. So this should also be wrong. So B should be the correct answer. Okay. So let's check it up. Yp is equal to 1 by d square minus 7d plus 12, and if you put 5 here in place of d, 5 square minus 7 into 5 plus 12 operating on e power 5x, which is e power 5x divided by 35 plus 12, 47, 25. This is 25 plus 12, 37, 37 minus 35 is 2 actually. So this is e power 5x by 2. But actually, without doing even this, you can figure out. By looking at this, you can say the roots are 3, 4. So that complementary function should be c1 e power 3x plus c2 e power 4x. So you can eliminate option A and option C. Also, when you calculate particular integral of an exponential, you know, like whatever happens, that e power 5x, e power x term keep sustaining in the solution. But here you do not have e power 5x. So you can eliminate that. Using these logics, you can eliminate 3 options and you can have the option B as the correct answer. Okay, you need not even put a pen on a paper, okay, to solve this. Hello. Let's go for the next case. Let's go for the next case actually here. So let's go for this case like 2. F of d operating on y is equal to sin ax plus b or cos ax plus b. The procedure is same in both the cases. So cos ax plus b, of course, sin ax plus b, sin of ax plus b or cos of ax plus b actually. So let's see. So let's take for example sine function. Okay. So yp is equal to 1 by f of d operating on sin ax plus b, of course. Okay. So this is the obviously the particular integral, because this 1 by f of d, it's a inversely operating on the sine of ax plus b. You'll get the solution. So let's pick it up and solve how we can do this. So replace d square by minus a square in f of d. Okay, this leads to yp is equal to 1 by some function, say g of d into sin ax plus b. Okay, then by rationalization or integration we get yp. Okay, so by rationalization or integration we get yp. So let's work an example to understand how this works out. Okay, so example, solve. So let's say d square y by dx square, say minus 5 times dy by dx maybe, plus 6 times y is equal to, because this is a common example, we can calculate the roots 2 comma 3 of course, 7 to 830 na, obviously every day. So d square y by dx square minus 5 times of dy by dx plus 6y is equal to, so let's say something like maybe sin 3x plus 4. You have this. Okay, then you know basically calculation of particular calculation of complementary function. So calculation of complementary function is not a very big deal for you at this stage. So auxiliary equation is something like m square minus 5m plus 6 is equal to 0. So the roots are going to be 2 comma 3. Okay, then what is yc in that case? c1 e power 2x plus c2 e power 3x actually here. Okay, so c1 e power 2x plus c2 e power 3x actually. Now let's see, if you have c1 e power 2x and c2 e power 3x, let's calculate yp. Okay, you will understand now. Yp is equal to 1 by d square minus 5d plus 6 operating on sin 3x plus 4. Okay, now what is the first step I have told you? Replace d square by minus a square. Okay, sometimes people confuse that. I told them to replace d square by minus a whole square. Okay, if it is minus a whole square, I would have straight away written just a square here, correct? But it is like minus of a square value. So first you calculate a square and then put a minus for that. Okay, that's how it works. So replace this d square by minus a square, d square by minus a square. So what is the value of a here? It is 3. So we can replace with minus 9 of course. Okay, so yp is equal to 1 by minus 9 minus 5d plus 6 operating on sin 3x plus 4 actually here. Okay, so if you simplify this, we get minus 1 upon 3 plus 5d. That's what you have. Okay, sin 3x plus 4, because minus 9 plus 6 gives you minus 3. This minus 5d is as usual, so I can take a minus up. Now further, to replace this d square with minus a square, you do not have a d square here. Okay, so if you do not have a d square, then what you gonna do? You create a d square by rationalization. How do you do that? So this implies yp is equal to minus 1 by 3 plus 5d into 3 minus 5d by 3 minus 5d actually here into sin 3x plus 4. This is what you can have. Okay, so once you have this, we get yp is equal to minus 1 upon, this is a plus b into a minus b, so 9 minus 25 d square times 3 minus 5d operating on sin 3x plus 4 actually here. Now by rationalization, you have again got a d square term. So let's see, by rationalization we again got a d square term actually, okay, in the denominator. Now once you got d square, again you can replace d square with minus a square. So replace d square by minus a square, which is equal to minus 9 of course in this case. Okay, because this a is 3, so minus 9. So if you replace d square with minus 9 in this option, we get yp is equal to minus 1 upon 9 minus 25 times minus 9. Okay, so 25 times of this d square can be replaced with minus 9 into 3 minus 5d operating on sin 3x plus 4 actually here. Okay, so this is what we have. Then this is just a constant. You can simplify. What is the value of the constant? Minus 1 upon, this is like minus 9. So if you take a minus 9 common, maybe it's like this is 25 into 9 plus 9 of course. Okay, so 9 into 26, 26 into 9, 6 9s are 54, 5 18 23, so 234. This is minus 1 by 234 is what you got. Okay, then let's simplify this value. First, this is 3 minus 5d operating on that 3x plus 4. So first, let's operate 3. 3 is just a constant, it just multiplies. Okay, so 3 into sine 3x plus 4 minus 5 into and d of sine 3x plus 4. We all know that d is actually the differential operator. So if you apply differentiation of sine is cos 3x plus 4 into this inner derivative, which is 3. So the final answer of yp is going to be minus 3 by 234 sine 2x 3x plus 4, then minus of minus is plus, 5 3s are 15 by 234 cos 3x plus 4. That's the particular integral of this case actually. Okay, so it's very simple. Like maybe it looks slightly lengthy, but generally these solutions are very simple to evaluate. Wherever you find d square in the denominator, you will just replace it with minus a square, and if you don't find a d square, then just by rationalization you can get a d square. Okay, and then substitute minus a square. That's all. Okay, it's simply done. So therefore, what is the complete solution? Therefore, y is equal to c1 e power 2x plus c2 e power 3x, and the particular solution, which is, so let's say plus 1 by 234 times of 15 cos 3x plus 4 minus 3 sin 3x plus 4. This is the solution actually here. Okay, so this is going to be the solution. Clear to all of you? Please type it in the chat box. Is this fine to each and everyone? Did you all get? When you have a sine function or a cos function, then just differentiate it, replace this d square with minus a square, and if you don't have a d square, just by rationalization or multiplying d on the top and denominator, you can get a d of course. Okay, let's try to solve it one more example to understand some more techniques. Okay, example, solve d cube y by dx cube is equal to sine square x. Okay, so let's say for example you have, or else let's say sine 2x for the time being. Okay, so let's solve this simple equation, sine 2x actually here. Okay, sine 2x, since we stay in the real plane of course. Okay, so since okay, so is this clear to all of you? So let's see, since we try to stay in the real plane, so solution, first of all, auxiliary equation is m cube is equal to 0 of course. So this implies the particular the complementary function is c1 x square plus c2x plus c3 into this is e power 0 into x, okay, which is 1 of course. So this is the complementary function. Now let us look at the particular integral. So calculating yp, so yp is equal to 1 by d cube operating on sine 2x actually here. Okay, so 1 by d cube operating on sine 2x. Then let's see, for this d cube can be written as d square into d. So 1 by d square into d operating on sine 2x actually here. Okay, so as usual, this d square can be replaced with minus of a square, so which is minus 4. So minus 1 by 4d into sine 2x. So this can be written as yp is equal to, this is minus 1 by 4 into 1 by d sine 2x. Now we have actually two options to proceed from here. One thing is, as I told you, if d is the differential operator, then 1 by d is actually the integration operator. Okay, so you can replace this 1 by d as integral. So this ultimately gives you yp is equal to minus 1 by 4 times integral sine 2x dx, and this guy gives you minus 1 by 4 minus cos 2x by 2 is what you get. So minus and minus gets cancelled, so it's like cos 2x by 8. This is the actual answer in this. Okay, so cos 2x by 8. This is one way to get this particular integral. Or at this point you can decide one more thing, you can multiply a d in the numerator and denominator. Okay, so if you multiply a d on the numerator and denominator, let's see, or let's say yp is equal to minus 1 by 4 times 1 by d operating on sine 2x. Okay, so what I can do, maybe I can replace this with a d and a square here. Okay, because just a rationalization, d and d of course. Then again this d square can be replaced with minus 4 of course. So if you replace with minus 4, it's like plus 1 by 16 into derivative of sine 2x. So this gives you, it is d of sine 2x, so derivative of sine 2x 1 by 16 times derivative of sine 2x is 2 cos 2x actually. Okay, so this value is going to be cos 2x by 8. That's it. Okay, the same way. So by rationalization, or if you are smart enough, you can just convert the integral this operators to integrals and you can solve. Clear to all of you? So wherever you can see d square, it's like differentiating it twice. Okay, similarly if you see 1 by d square, then it's like you can integrate it. Okay, similarly you might have solved this question here also. Okay, so if you integrate it for the first time, this can be written as, see, I'll just show you one thing. When you have this yp is equal to 1 by d cube sine 2x, you would have also done it as, of course, by replacing d square with minus a square, it got simplified soon, but you can also do this 1 by d of sine 2x. Okay, and this 1 by d is nothing but integral sine 2x dx. So this ultimately gives you 1 by d square into minus cos 2x by 2, right? This is the integration value. Okay, because integration of sine 2x is minus cos 2x by 2. Again you can split this 1 by d square as 1 by d into 1 by d, of course, and minus cos 2x. Okay, this 2 is just a constant. I am pulling it out of the out of whatever integration or differentiations. So minus 1 by 2 into 1 by d into this 1 by d is integral cos 2x dx. So this tells you minus 1 by 2 into 1 by d, integration of cos 2x is sine 2x by 2 actually here. Okay, that's one thing. So again you can pull the 2 outside. So yp is equal to, so minus 2 2s are 4, 1 by d operating on sine 2x, which is something like minus 1 by 4 into this integral sine 2x dx. So this tells you minus 1 by 4 minus cos 2x by 2, so which would have again given you cos 2x by 8. So here the basic idea is, when you see things like 1 by d, so how 1 by d becomes integration, because d is the differential operator actually. So 1 by d is like the inverse of d. So inverse of differentiation is integration. Got it? D is not just like a, of course we are solving in case of polynomial equations and all, but the actual effect of d is it's a operation, differentiation. Okay, so 1 by d is same as d inverse, so that actually tells you inverse of the differential operator, which is a integration. Clear? So that's how the answers in this case, or whatever the two cases you take, it matches always. Fine. So if there is no d square in the denominator, by rationalization or by adjusting whatever the d's you have, you can simplify this. Clear to all of you? Yeah. Then let's solve one more case, like third case. F of d operating on y is equal to, say, x power m. You can have polynomial functions sometimes. Okay, so this is equal to x power m actually. So let's see in this case, if you have x power m, then just you calculate this as 1 by f of d operating on x power m. So this can be written as f of d power minus 1 x power m. So you will figure out what is this operator and then you will apply it on x power m actually. Okay, so let's see an example basically to understand this straight away. So solve some coefficients I'm writing is equal to, say, x cube for example. Okay, so this is x cube in this case. This maybe I have taken a power 2 with 3, okay, on the top of x. Maybe the m value what I'm taking is x cube. Okay, so as per, so complementary function, all this is fun stuff now. So yc is equal to, I'm directly writing, by this time many of you can understand, 1 comma 2 are the roots. So c1 e power x plus c2 e power 2x actually here. So these are the roots till this point, so there is no issue up to this point. Okay, now let's calculate yp. Okay, so how do we calculate yp? Let's check it. Yp is equal to 1 by d square minus 3d plus 2 operating on x cube. Okay, so this is what you get. Now there are two options from this point to proceed. Okay, what are the two options? Let us check. First option, okay, first I'll show you one solution. Anywhere you can write this as, if you take 2 common, it's like 1 plus d square minus 3d by 2 operating on x cube. Okay, so you have operating on x cube actually. So this is x cube, which tells you yp is equal to, this 2 is constant of course, 1 by 2 into, can I write this as 1 plus d square minus 3d by 2 whole power minus 1 operating on x cube. This is what of course I have written, but this 2 is just a constant, so I have pulled it out. So once you have this function, then since I have taught you binomial expansions, you might have remembered. Okay, so we have, if you have remembered, 1 plus t whole power minus 1 we have given as 1 minus t plus t square minus t cube and so on, correct? It's a geometric progression basically. Okay, we have written this. So similarly we can write it this as yp is equal to, this 1 by 2 is of course here, 1 minus d square minus 3d by 2 plus d square minus 3d by 2 whole square. Okay, so just for the simplification, just to reduce the length of the problem, let's keep x square here. Okay, just only to reduce the size of the solution, nothing other than that. The process is same, so just put it as 2 because the solution size would be slightly less. Okay, otherwise it comes very lengthy. Okay, that's all. So plus d square minus 3d by 2 whole square minus d cube minus 3d by 2 whole cube plus and so on operating on x cube actually here. Okay, so this is x square is x square actually. Okay, because even if it's x cube, the same thing would have happened. Then let us apply each and every term on x square. So yp is equal to 1 by 2 is just anyhow you have. Now 1 is just a constant. Okay, so 1 operating on x square would just give you a x square minus this 1 by 2 is here, 1 by 2 into d square. So d square is like second derivative of x square, correct? So what is second derivative of x square? First derivative is 2x, second derivative is 2 actually, 2 minus 3 times of derivative. You have to do this calculation very carefully. Okay, many times students mess up with the plus and minus signs and they end up with the wrong answers. Okay, so please be careful. It's like d square is the second derivative of x square, which is 2 minus 3 times of first derivative of x square. So what is the first derivative of x square? 2x. Okay, it is done. Then plus 1 by 4 into, so 1 by 4 into, because this 2 square will actually give you 1 by 4. If you expand this, okay, so if you expand this, you will have d power 4 minus 6 d cube plus 9 d square operating on x square. Okay, because this d square minus 3d whole square will actually give you this term. So when this is a quadratic function, and if you are doing fourth derivative or third derivative, the answer would be zeros. Okay, so 9 into d square of x square. So you have 9 into d square of x square, which gives you 2 of course here. Okay, so this is 2. Then from this term onwards, the minimum degree of d is going to be 3. Okay, means the minimum degrees you have is third order differentials, and if you apply a third order differential on a second degree function, ultimately from this term onwards, every higher order term will give you a derivative 0. Okay, so this sequence, or basically this series, will end at this point actually. Okay, because all further terms would give zeros. If this is x cube, you would have taken the effect of this d, because this last d will give you only d cube term. So then the effect of this d cube would also have been there here. That's all. Okay, other than that nothing is changing. So if you simplify this, yp is equal to 1 by 2 times of x square minus, then minus 1 into 1 minus 3x, 1 minus 3x, and plus 9 by 2 is what you have. Okay, 9 by 2 is like 4.5. maybe you can do this. So x square by 2 minus 1 minus of minus plus 3x by 2, then minus 1 plus 9 by 2. So 9 minus 2, 7 by 2. So plus 7 by 4. This is the particular integral in this case. Clear? This is one way in which you would have got the solution. Fine. Is this clear? Because this expansion is, when you expand this d square minus 3d whole square, whatever the expansion I would get, d power 4 minus 6d cube plus 9d square, that I have operated on this x square and finally figured out it's only 9 into 2 actually. Yes, is this clear to each and everyone? Please type it in the chat box. Got it? Everyone, Alpha Salam, Do Singh, Bambabu, Thakur, Krishnaveni, I could read names, Ravan Singh. Yeah, is this clear to each and everyone? Did you all understand how the process goes on? Now one alternative way in doing this is, you can say, or yp is equal to x square. Okay, this can be written as 1 by d minus 2 minus 1 by d minus 1 operating on x square. Correct? I would have done into partial fractions. Okay, I can convert this guy into partial fractions, and obviously here I could have got, so if you take a minus 2 out actually, okay, then this would be 1 minus d by 2 minus or plus 1 by 1 minus d operating on x square actually. Okay, so it's just a partial fractions, and that partial fractions I can write it this way. So it's like minus 1 by 2 times 1 minus d by 2 whole power minus 1 plus 1 minus d whole power minus 1 operating on x square. So this can be written as minus 1 by 2 times of, if you expand this, okay, 1 plus d by 2, because it's like 1 minus d whole power minus 1, so 1 plus d square and so on. So plus d square by 4 plus d cube by 8 and so on. This operating on this x square plus this function also operates on this x square actually. Okay, so which gives you again 1 plus d square plus d cube and so on operating on this x square actually. Okay, because I can split this function into two parts, you can individually see this function operating on this x square plus this function operating on x square. Okay, I can write that. So if you do this simplification, minus 1 by 2 times of 1 into x square is x square plus 1 by 2 into d of x square is 2x plus 1 by 4 into d square of x square, which is the second derivative, which is 2, plus 1 by 8 into third derivative of x square, fourth derivative of x square. All these terms are 0, so this will end here, plus 1 operating on x square plus derivative of x square, second derivative of x square and so on. That's it, it is 0 actually. Now if you perform this simplification, let's check it up. Minus 1 by 2, okay, directly let's multiply. Minus x square by 2 minus x by 2 minus maybe you can cancel this and make this to be 2. So minus of 1 by 2 into plus 1 by 2, so this is minus 1 by 4 plus x square plus 2x plus 2 actually here. Okay, so if we simplify, x square minus x square by 2, 1 x square by 2, okay, plus this 2x minus x by 2, so 3x by 2, correct, it is like 2x, right? So 2 if you cancel, so 3x by 2, then plus 2 minus 1 by 4, so 2 minus 1 by 4 is 7 by 4. Okay, so that's the answer. So if you check the particular integral calculated in this case and in this case, the answer is same. Okay, so x square by 2 plus 3x by 2 plus 7 by 4 and x square by 2 plus 3x by 2 plus 7 by 4. So it always we have multiple ways to solve a particular question. Looking at this, many of you may feel it is very simple. Okay, basically this method is much advantageous than compared to this method because it involves some hectic calculation. Okay, but this method is always applicable. I mean, both the methods are always applicable, but sometimes when the roots of this equation are complex and all, it's not very comfortable for you to write in partial fractions. Got it? That's the main difference. Okay, in the first method you have a restriction, you can always use that method happily and you can solve. The only thing is just squares, cubes, these terms comes in excess. But here when this function, let's suppose I have given you cubic function, okay, then writing partial fractions is not very easy job. Also, if the roots are coming out to be some complex numbers of this, okay, then writing the partial fractions and simplifying this is not easy stuff. Okay, did you understand this? Fine. Is this clear to each and every one of you? All of you, just type it in the chat box. Yes or no, please type it in the chat box. All of you, whoever is on live, everyone, please type it in the chat box. Okay, so let's go for one question, maybe if I can. Okay, we had some questions on Euler, Cauchy maybe, so fine. So I'll give you one example, so try to calculate this value. Okay, or else we can go for an example later, just let's continue. 4. If f of d operating on y is equal to e power ax times x. Okay, so if you have a function capital X here, okay, Normally this is also a function of x, but let's say if this is of the form e power ax into x, okay, then yp is 1 by f of d operating on e power x into x, and this implies yp is equal to 1 by f of d plus a times x. Okay, so just a second, there's a e power x. So this is one conversion. Again, how you can go for this. Okay, so yp can be converted in this form. So ultimately, with the rules whatever I have given you, you can figure out what is this particular integral again. Okay, I'll give you one question, so just try to answer this example or solve d square y by dx square minus 6, let's say 6 dy by dx plus 9y is equal to, let's say, e power 3x by x square. Okay, so let's say if you have this, so let us make an attempt to solve this question and we'll understand how this logic actually works. Okay, so let's solve this question. Given d square y by dx square minus 6 times dy by dx plus 9y is equal to e power 3x by x square actually here. Okay, so once you have that, then ultimately if you look at auxiliary equation, so first part, calculating yc. Now this is a bit of fun business, let's do. Auxiliary equation is m square minus 6m plus 9 is equal to 0. So ultimately m is equal to 3 comma 3. So yc is equal to c1x plus c2 e to the power 3x. Okay, so till here it's known to you. Everything is we have repeated this so many times. Then let's see how to calculate yp actually. Okay, so yp can be calculated in this way. Look, calculating yp. So this tells you yp is 1 by d square minus 6d plus 9 operating on e power 3x into 1 by x square. I can write this, okay, because e power 3x by x square can be written as e power 3x into 1 by x square. So now this function is exactly of this form. Okay, so you have some exponential product into capital X, of course. Okay, so if you try to solve this, what I'm telling you is yp is equal to 1 by some function. This can be written as d minus 3 whole square, okay, because you can clearly see d minus 3 whole square operating on e power 3x into 1 by x square. So this can be written as e power 3x into, because you can check, I have taken this e power ax out and replaced this d with d plus a. Okay, so e power 3x into 1 by d can be replaced with d plus a operating on 1 by x square actually here. Okay, that's what you have, because if you have d, this d can be replaced with d plus a, so therefore d is replaced with d plus 3 and this e power 3x is taken out. So then ultimately this function becomes 3 gets cancelled. So okay, so yp is actually equal to e power 3x into 1 by x square, 1 by d square operating on 1 by x square. So now there are plenty of techniques in which you can solve this. Okay, one technique which whether I would prefer is 1 by d into 1 by d on 1 by x square. Okay, so then ultimately it gives you 1 by d into, it's like integral 1 by x square dx e power 3x times 1 by d into, now integration of 1 by x square is minus 1 by x, correct? So minus sign you take out, minus e power 3x into 1 by d of 1 by x, integral 1 by x dx, which is ln x. That's it. Okay, so this is how we can calculate the result, and yp in this case is minus e power 3x times ln x actually. Therefore the complete solution c1x plus c2 e power 3x minus e power 3x into ln x. That's the complete solution actually. Okay, fine. So did you understand? Whenever we have this product of exponential into some function, you can take out this exponential out of this operator by replacing this d with d plus a and simplify accordingly. Okay, everyone, please type it in the chat box. Is this clear to all of you? Okay, Just quickly type it in the chat box. Fine. So then let's see. I'll give you one question. Just try to solve this. If the solution of y by dx square minus 7 dy by dx plus 12y is equal to, say for example 6. Okay, so let's say this is the solution. This is the equation. Is y is equal to c1 e power 3x plus c2 e power 4x plus some constant k. The value of k is dash. Come on, solve this question. I'll give you for the previous question, the answer is like option B. You have done. So some of you have marked it correct, Ashwini. So for this question, integer type and start. Solve this question. Yeah, I'll explain one more time. Okay, first try to solve this question. Whenever we have e power ax times some function, that e power ax can be brought outside the differentiate operator by converting the d in the denominator as d plus a. Okay, you can replace d with d plus a and you can bring out the exponential function out of the operation actually. Okay, so solve this question. It's okay, Kilesh, you can just, it's 1. That's so. No, it's not 1. All York, Kailesh, Dov, Ram, Alpha Salam, Vaishnavini. It's quite possible you can think that it's 1, but it's not actually 1. Thanks, York. So let's solve this question basically. So one thing that might come in your mind is this is complementary function, correct? There is no change in this. That's complementary function obviously, because if you calculate yc, then c1 e power 3x plus c2 e power 4x. Now this k is basically the particular integral sum. Okay, so let's see. Yp is equal to 1 by d square minus 7d plus 12 operating on 6. Correct? Now how to solve this question? Exponential function e power x. Is that we can make? Yeah, we can make exponential function with the value being e power 0x, because e power 0x is 1, so you can do. Okay, so this 6 is just a constant, you can take it out. So you replace d with a. That's it. Okay, so 0.5 is the actual answer. Got it? So therefore k is equal to 0.5. Okay, so I hope it's clear. So what is the, anyway, so this is the value. So when they give you constants, there are plenty of ways in which you can work out. One easiest way is to put exponential, or else you can write x power 0 and you can start differentiating and all, but again that was like a Yes, I was a math student, but I don't know about mathematics. Oh, no, I completed my 12th doing. Okay. Can I become a well-known person of maths by practicing engineering maths? Definitely. Yeah. If you, in fact, if you want to, if you feel that you are lacking basics in engineering maths, you can definitely go for NCERT books one. Okay, no issue. There's nothing wrong in learning things from scratch. You can just look at it. Okay. So let's go to the concept of Wronskian. Okay. So before talking about the concept of Wronskian, or basically this is also called as okay, let's see the concept of Wronskian first of all. If you have an equation, if say y double dash plus some function of y dash plus some q of y is equal to some x. Okay, so let's say this is the equation. So somehow let's say you got these solutions. Okay, if equal to x and yc is equal to c1 into say y1 of x plus c2 into y2 of x with the complementary function. Be the complementary function actually. Okay, so let's say this is the complementary function. Then we define Wronskian as then the Wronskian W of y1 y2 is actually given by y1 of x, y2 of x, y1 dash of x, y2 dash of x actually. Okay, so this determinant is actually called the Wronskian of course. Okay, so what does this Wronskian actually tell you? Basically, first of all, this Wronskian is actually used to calculate the particular integrals, and this Wronskian also tells you the strong dependency of the two functions. Okay, this Wronskian should never be 0. Obviously it will not be 0 actually here. Okay, so Wronskian value is not 0 actually, and you can see once you know the Wronskian value, the particular integral yp integral, I'm not again showing the derivations and all, but normally you can show. So just the particular integral yp is equal to minus y1 integral y2 x by Wronskian dx plus y2 integral y1 x by Wronskian dx. Because whenever the formulations I've given you only for some standard functions like exponential function, power function, sine of ax plus b or cos of ax plus b, only these kind of functions. Okay, but what if there's a log? Okay, then what if there's some other function? So in such cases, this normally this is also called as method of variation of parameters. Method of variation of parameters actually here. Okay, so this Wronskian method is same as method of variation of parameters, and in this question, whatever the y1 you use, because if y1 and y2 are taken, you can choose any one to be y1 and any other function to be y2. Then out of these two, you can say you can choose y1 to be anything, but whatever the y1 you choose here, same y1 you should choose here when you are writing that. Okay, you cannot change in between. Okay, so this is the solution. Also, I want to tell you one more thing. Look, if y is equal to c1 times y1 of x plus c2 into y2 of x is a solution, or let's write it in a different way. If the same statement, but of course in a slightly reformed way, if y1 of x comma y2 of x are linearly independent, we have seen this word linearly independent in matrices, of course, are linearly independent solutions of say something like maybe d square y by dx square plus some p into dy by dx plus q into y is equal to 0, then any linear combination, if you call this equation to be 1, okay, so this is equation 1, then any linear combination of y1 of x and y2 of x is also a solution, okay. So what do you mean by linear combination? That is C1 y1 of x plus C2 y2 of x. So if you take any linear combination, then that's also a solution of. Okay. Sorry, so are you teaching M1, M2, M3 too? I mean those topics from M. Basically, I'm teaching engineering mathematics, and different universities and different basically different colleges, they plan what should be in M1, M2 and M3. Okay, but this engineering maths, if you learn in a good way, it's going to help in all the subjects. Clear? So let's see. This is like, so let me tell you with the help of an example so that you can understand. Example. For example, let's say if you have d square y by dx square minus 4 times of dy by dx plus 4y is equal to 0, which I have given you as one of the solution. Okay. Ultimately, you know, since the homogeneous, this equation is homogeneous, so complementary function itself is the complete solution. C1x plus C2 e power 2x. This is the solution, of course. Okay, so you have this. Then in such case, you can write this as C1 into e power 2x, or C1 into x e power 2x plus C2 into e power 2x actually. So this is the solution which you know. Okay. Now let's say this C1 C2 can be any arbitrary constants, because when you are defining the solution, C1 and C2 can be any constants. So if C1 is equal to 0, then this implies, and C2 equal to 1, because you can choose anything, then this implies y is equal to e power 2x, which tells you y equal to e power 2x will actually satisfy this equation, which if you want you can check. If you just calculate y dash is 2 e power 2x, y double dash is 4 e power 2x. If you put in these terms, the equation gets satisfied. Okay. Or if C1 equal to 1 and C2 is equal to 0, even then in that case also y is equal to x into e power 2x. So ultimately here also, if you calculate y dash and y double dash, and if you substitute here this equation gets satisfied. Okay. So you can observe something. These two solutions are linearly independent. Linearly independent. The reason is, so for example, let's say this is, I call it as y1 of x and y2 of x. You can never express y2 of x is equal to some constant times of y1 of x, correct? Because this variable x will never get reflected. Okay. So you cannot write some constant times y1 plus some constant times y2 equal to 0. Okay. You can never write this, obviously. Okay. So if these two are the solutions, any linear combination of these two. Okay. So if these two are linearly independent solutions, then you take any combination. What are the values of C1, C2 you take? Okay. Like it's 2C1 plus 2 into this plus 3 into this, whatever, any combination you take, that will always satisfy the equation. That's what this actually tells you. Okay. So this is a bit important in this case. Clear? When you have y1 of x and y2 of x independently satisfying the equation, any linear combination of the two solutions will also satisfy the equation. That's the main thing. Got it? Did you all understand? Okay. Fine. Is this clear to all of you? Please type it in the chat box. Okay. So let's solve one question based on this Wronskian. So solve this question. Okay, this is Euler Cauchy maybe. So I'll give a simple question based on the Wronskian value. There should be one question, right? Based on the, I think the slide by mistake got deleted, but yeah. Okay, so no issue. Let's take it up. I'll show you one question actually. So let's solve this same question, whatever I have given you. Solve d square y by dx square minus 6 into dy by dx plus 9y is equal to e power 3x by x square. Okay, so we have seen this question today. So we have also figured out the solution. So you can check, this is the question. Okay, so that's the question. So if you solve this question, you have got the answer to be C1 into x e power 3x plus C2 e power 3x minus e power 3x into ln x. Okay, so this is the solution. Let us try to solve this question by using method of variation of parameters. Okay, so firstly, if you calculate auxiliary, the complementary equation, you know, yc is equal to, I'm writing it directly, C1 x e power 3x plus C2 e power 3x this is what you would have got actually, okay, or c1x plus c2 e power 3x. So if you multiply individually, because I was interested to write c1 into some function of x plus c2 into some function of x, so let us write it this way. So let us choose maybe like let y1 of x is equal to x e power 3x and y2 of x is equal to e power 3x. Okay, so let's take it this way, or else if you want you can exchange also, doesn't matter, it's just a matter of choice. Okay, then let's see if you calculate Wronskian value is Wronskian of y1 y2 is equal to y1 of x, y2 of x, y1 dash of x and y2 dash of x actually here. Okay, so this is what you get. Ultimately if you substitute the functions, you have x into e power 3x, this is just e power 3x. Then if you differentiate this first function into derivative of second function plus second function into derivative of first, which is 1 of course. Okay, then derivative of this function is 3 e power 3x, that's all. Okay, so let's simplify the result. We have something like, you know, e power 3x, if you take common from this column and also from this column, you have e power 6x, e power 3x into e power 3x. Just if you calculate the determinant, okay, then this is like x 1 3x plus 1 into 3. Okay, so if you simplify this, e power 6x times of 3x minus of 3x minus 1, so this is minus 1, so minus e power 6x. This is the value of the determinant, correct? Yes or no? Please confirm. That's the value of the determinant. Minus e power 6x is coming out to be the value of determinant actually. True? Yes or no? Please type it in the chat box. Correct? Because here you can take e power 3x out, and here also you can take e power 3x out. x1 3x plus 1 3x 3x minus 1, so minus e power 6x is coming out to be the value of the determinant. You calculate, it's just a determinant calculation, nothing a very big deal in this. Okay, in examination please don't waste time in thinking whether it's y1 dash and y2 dash or not. Okay, you take anything, the answer remains same, because this, if you write y1 dash here and if you write y2 here, it's just the transpose of that. Okay, so determinant of a matrix is same as determinant of its transpose, we have seen. So this minus e power 6x is the value. So Wronskian value is e power minus 6x. Now let's come for the particular integral calculation. So therefore yp is equal to minus y1 integral y2 x by Wronskian dx plus y2 integral y1 x by Wronskian dx actually here. Okay, so if you substitute, yp is equal to minus y1. So we have taken y1 to be this function, we have maintained the same thing, so you should definitely take y1 this. In this case, if you have chosen the opposite way, you would have done the same thing, and here also you would have maintained the same thing. Whatever you make the choice here, you should maintain the choice all over. Okay, so y1, so what is y1? X into e power 3x into integral y2. So what is y2? E power 3x into x. X is e power 3x by x square, so that's the value of x, into this Wronskian. So Wronskian value is minus e power 6x dx plus y2. What is y2? This guy, integral y1 is x e power 3x into this capital X, e power 3x by x square, and Wronskian is also there, so which is minus e power 6x dx. This is the function actually here. Okay, so if you simplify these integrals, let's see, e power 3x into e power 3x, this e power minus 6, e power 6x gets cancelled. Similarly, you can cancel up here. Then let's see, we have something like yp is equal to minus x into e power 3x, or else this minus and minus can be, you know, these guys can be given up. Then we have yp is equal to x e power 3x integral 1 by x square dx plus, or else by taking this minus sign out, so minus e power 3x into integral 1 by x square dx actually here. Okay, so that's what we have. So ultimately if you take the values, yp is equal to x e power 3x integration of 1 by x square minus 1 by x minus e power 3x into integration is minus 1 by x. Okay, but here you can understand something, this x and this x gets cancelled, so yp is equal to minus e power 3x minus of minus plus 1 by x into e power the x actually here. Okay, so this, oh sorry, here I made a mistake, just a minute. We left one x here. You can observe this x can be cancelled here. Okay, so here instead of x square you have only x, then this gives you ln x. Okay, that's it, because there is an x here inside. Okay, these things you will miss. Okay, you have to be a little careful. So minus e power the x minus e power the x times ln x. This is actually the pi p value in this case. Now if you look at the total solution of the differential equation, so therefore total solution of the differential equation, if you look at it, this yc which is here, okay, c to e power the x plus yp which is this. Then you can understand one thing, this c2 is just arbitrary constant, it's just a constant, whatever the choice you make, this is always a valid solution. So can I send this minus 1 inside this, means can I write this part as c2 minus 1 operating on e power the x, and c2 minus 1 is just one more constant, so which is capital C, maybe some other constant if you write. So this gives you y is equal to some c1 x e power the x, or c1 x plus you write this as maybe some capital C2 whatever, some other constant, times e power the x minus e power the x into ln x. Okay, and this is the same solution what you got by the other technique what I have taught you. Yes, is this clear to all of you? So the main idea is calculation of particular integral using this expression is the main thing. Okay, you have to put it correctly, put y1 and y2 correctly in the solution. Okay, again, to be frank, I'm not giving the proof of this expression because it's very again some manipulations and all are there which I feel not necessary at this point. Okay, so is this clear to all of you? So if this is clear, then we'll move to the last part, which is the Euler-Cauchy equation. Okay, put a heading Euler-Cauchy equation. So please make a note for this particular integral formulation. Okay, so this is the way how you calculate. Then let's look at Euler-Cauchy's equation. So it is something like equations convertible from nonlinear to linear we have done after first order equations. Similarly, equations convertible from linear coefficient to what you can say, equations with variable coefficients to constant coefficients conversion. Okay, so let's see this equation of the form, the equation of the form x power n nth derivative of x power n, this is one special case of coefficients, plus k1 some constant into x power n minus 1 d n minus 1 by d x power n minus 1 plus k2 x power n minus 2 d n minus 2th derivative of y by d x power n minus 2 plus and so on, plus k n minus 1 times x into dy by dx plus kn of y is equal to some function in terms of x actually. Okay, so this equation is basically called the Euler-Cauchy equation actually, where the coefficients are variables. You can see it's not constant coefficient, okay, because you have power of x. Okay, but the variables are exactly in that particular form where this x power n minus 2 is actually same as d power n this derivative actually. Okay, the order of the derivative is same as the degree of the x actually in the coefficient. Clear? So in this case we can make a substitution. We define an operator by defining an operator d is equal to d by, you can say by defining an operator d equal to d by dz, where x is equal to e power z, because you want to define what is this d actually. So this z is actually x is equal to e power z, and obviously this implies z is equal to ln x. So by making this substitution, if you take x is equal to e power z actually here, then this implies ultimately your x into d by dx can be written as this capital D actually. Okay, this can be easily shown by the chain rule. You can check if you want x into dy by dx, for example. Okay, this I can write this as x into By making a small manipulation, can I write this as dz by dx into dy by dz? Can I write it this way? Yes or no? So that dz get cancelled, I'll again have the same thing. Okay. So now what is dz by dx? Z equal to ln x. So if you differentiate this, dz by dx is equal to 1 by x. So if you replace here, x into this part turns out to be 1 by x into dy by dz. So this x gets cancelled, which means if you have a operation x into d by dx operating on y, this is same as d by dz operating on y, and we are taking this function as capital D. That's the differential operator what I have chosen. Okay, so therefore this x into d by dx means this operating on y is same as this d operating on y because of this logic. Similarly, if you apply chain rule and you can show x square times d square by dx square, this is going to be d times of d minus 1, x cube times d cube by dx cube. This can be equal to d into d minus 1 into d minus 2 actually, and so on in general. Is this clear to all of you? I have shown for first degree, but similarly you can work out for second degree also. It's slightly lengthy compared to this. Okay. Fine. Is this clear to each and everyone? Type it in the chat box. This is just because of some chain rule kind of thing, just a bit of adjustment, that's all. Okay, then let's see if you have this, if you replace this back onto this equation. Okay, so let's call this equation to be equation 1. Fine. So if this is the equation, wherever there is x, you can replace with e power z, z can be replaced with log x, whatever. Then substituting x into d by dx is equal to d x square d square by dx square is equal to d times of d minus 1 and blah blah blah. You can check it up. The equation 1 implies, so this can be written as x power n d power n by dx power n. Okay, so if you write this operator, so let's see. Okay, so x power n d power n by dx power n plus k1 times x power n minus 1 d power n minus 1 by dx power n minus 1 plus k2 times x power n minus 2 d n minus 2 by dx power n minus 2 plus and so on plus k n minus 1 x d by dx plus k n. This whole thing operating on y is equal to x actually here, correct? So that's the actually equation 1. Now if I replace this with the d, where d is this d by dz, okay, and this is purely a function of x, so this becomes a function of z actually by replacing x is equal to e power z. So wherever there is x in that function, you can replace x is equal to e power z. So this complete function in terms of x gets converted to completely in terms of z actually. Okay, and this x square into d square by dx square, that can be replaced as d into d minus 1 and so on. So this actually gives you some function operating on d, some function of d operating on y is equal to some function in terms of z actually. Okay, and now once you check this equation, in this f of d, the coefficients are variables or constants? Can someone tell me? If you look at the constants, if you look at the coefficients of d in this operator, basically in this, if you make this substitutions d, then this part can be replaced with some function of d again. This can be replaced with d into d minus 1 into and so on. So if you make these substitutions, then this part f of d will have the coefficients to be constants or variables. It will be constants, right? Yes or no? Because only you have one k1 into something in terms of d, k2 into something in terms of d. That's what you have. You will not have this x power n, x power n minus 1. This get rid of. Okay. So in such case, we can see. So this is linear ODE with constant coefficients, in terms of z and y actually here. Okay, so you know we have seen so many solving techniques for this equation, so which on solving gives you y is equal to some function in terms of z actually. Okay, the final answer would be in terms of z, of course, and by replacing z equal to log x, by replacing z is equal to ln x, we get the solution in terms of x. Clear? Did you all understand how it happens? Okay, is this clear? Just by making the substitution x is equal to e power z, the x into the variable into the differential coefficients whatever you have, you can write that as linear operators and you can solve it. Maybe you can quickly solve one question. So let us try to solve this question actually. Okay, so they have given you, so I'm solving it. Look, solution given x square y double dash plus x y dash minus y is equal to x actually here. Okay, and of course x is positive in terms of arbitrary constants c1 and c2, the general solution of this equation. Okay, so what is the general solution? Of course we'll calculate the complementary function and also the particular integral. Let us check it. So this equation is x square d square y by dx square plus x into dy by dx minus y is equal to x actually. So it's a purely a function of x, it's a non-homogeneous equation. So let's see, let x is equal to e power z and this implies z is equal to ln x. So we can differentiate x into d by dx. This becomes capital D x square times d square by dx square. This becomes d into d minus 1 where d is d by dz. It's a differential operator with respect to z. This is the story what I have taught you till now. Okay, then if you replace it back, this becomes this x square into d square by dx square, it becomes d into d minus 1 plus x into d by dx becomes d minus 1 operating on y is equal to x can be written as e power z actually. Okay, so if you simplify this equation, we have d square minus d plus d minus 1 operating on y is equal to e power z. D square minus 1 operating on y is equal to e power z. So this is a linear ODE now. Linear ODE with constant coefficients in terms of with constant coefficients. Okay, and this ODE is in terms of y and z actually here. Okay, now we can solve this equation. So ultimately, so calculating, oh sorry, I think I have chosen a wrong color. Calculating yc. So if you calculate yc, ultimately auxiliary equation becomes m square minus 1 is equal to 0. So m equal to plus or minus 1. So this tells you y of z is equal to c1 e power minus z plus c2 e power z actually here. Okay, because it's in terms of z, so this solution should be in terms of z actually. Now calculate yp again. Calculate yp. Yp is equal to 1 by d square minus 1 operating on e power z actually. Okay, so ultimately if you, this coefficient is 1, so if you replace d with 1, this answer is going to be 0. So which we can write as z into 1 by 2d operating on e power z. So now if you put z is this d equal to 1, this just becomes z e power z by 2 actually. Okay, so that's the particular integral. Just the common technique, only the variable got changed from x to z, that's it. The procedure is same whatever I have done. If you put d equal to 1 here directly, it becomes 0. So x into 1 by this derivative into the same function, so it's in terms of z, so z into 1 by 2d into this function. So if you replace this d with 1, so this is what you will get directly, z e power z by 2. So let's see the complete solution. c1 e power minus z plus c2 e power z plus this particular integral which is z into e power z by 2 actually. But what is z? We have the actual equation, the original equation in terms of x and y. So so substituting z is equal to ln x. This implies y is equal to c1 by x, because if x is equal to e power z, e power minus z is 1 by x, plus c2 into e power z is x, plus e power z is x, this z is ln x by 2. That's all. Okay, so c1 by x plus c2x plus x ln x by 2. So you can check option C is the correct answer. c1x plus, of course, c1 c2 are just arbitrary constants, the notations can be different. So some constant into x plus some constant into x power minus 1, which is 1 by x, plus x into ln x by 2. That's what you have. Okay, option C is the correct answer actually. Got it? So did you understand how to solve Euler-Cauchy equations actually? Once you get the final solution, if they give you boundary conditions, you can just substitute and get the constants. The same job what we are doing since the beginning. Okay. So maybe I'll give you one homework question. Solve this question. Okay, so solve this homework question. So in today's class, basically we talked about the particular integral calculations. We talked about the Wronskian, and towards the end we have also seen about Euler-Cauchy equation. So those are the things we have. Okay. So I think maybe in the last I have rushed a bit fast, but I don't think there's nothing like very complicated topics actually. Okay, it's the same stuff what we are doing. It's just like a conversion. Okay. And I hope there is no issue doing that. Fine then. Okay. So is this clear to each and everyone? Please type it in the chat box. So thank you all. Then okay. Yeah, thank you. Bye.